Hey, this is Scott. We're going to take a look at section 8.3 today, the third section, chapter 8. This one deals with inverse proportion. It says inverse and combined variations. I always call them inverse related proportions with all that. This is on page 366. Once again, like in 8.2, I kind of just talked about how I always approach these things and how I always taught them to my students with that too. Same type thing here with this one. I'm going to kind of go through the way that I would show you with that too. There's some other examples in the book, but this gives you another option too with all that too. Inversely proportion ratios ratios are when one number increases, the other number decreases. That's going to be ones that are inversely related. So, for example, the first one they use there is 5 machines finish something in 12 days. Well, how many days would 8 machines take? And that's going to be inversely related, because if you add more machines, it's going to take less time. Okay, so that's something that is inversely related. Gears is another one, with the teeth on the gears. That is something else that is always inversely related with that too. So those are some things to keep in mind. And once again, it talks about here on page 367 about why estimation is important. So you can look at the problem and go, oh yes, my answer is reasonable with that, or wow, that doesn't seem right. How did I come up with that? So let's try it again that way too. So, but anyway, remember last time in section 8.2, I'm going to flash back here just a second. In direct proportions, I said we wanted to make sure that we had things set up directly above each other with all that. So if you were going to work for 10 hours and you were going to get $100, if you're going to work for 17 hours, how much money would you get? Okay, once again, that's direct proportion. So you're going to work more time or you get more money. Okay, and we set these things up above each other. Hours over dollars, because this would have a label of dollars that way too. Now, with indirect proportions, what you're going to want to do is you're going to want to set those up so they are not above each other. So for example, on page 366, it talks about the machines problem. If 5 machines finish it in 12 days, 8 machines would finish it in how many days? Okay, so here we would go 5 machines, and since this is an indirect proportion, you put it on the other side of the equal sign. Finish it in 12 days, so 8 machines would finish it in how many days? This is going to be our variable here. We'll call it x. So you still cross multiply to solve. So 5 times 12 is going to give you 60 equals 8x. Divide each side by 8. Divide each side by 8. So you're going to get x. Oops. X is equal to 7.5 days. Now, does that seem reasonable? Yeah, it seems reasonable, because as the number of machines went up, the number of days should go down, and in this case it did. So that would be reasonable with that too. But now see, what I did here, instead of having machines, we knew 5 machines in 12 days, instead of having them directly above each other, they're not directly above each other. So with an indirect, they go this way. So you're end up multiplying those things by each other with all that. So that's going to be more of your indirect proportions that way. As I mentioned, gears are another one too with that. So if you've got a gear here, arrow down just a touch, and this example is on page 368. You've got 10 inches and 25 RPMs in one gear, and you want to know number of RPMs in a gear that's 5 inches, and question mark for RPMs. That's a question mark. It looks like a 7. That's a question mark. That's even a worse question mark now. But anyway, so I take 10 inches, and once again, since it's indirect, I don't put it directly below it. I put it over here, 25 RPMs, and then I put the 5 inches here, and then I put my variable right there. So once again, I would take 10 times 25, and I get 250, and that's going to be equal to 5x. Divide each side by 5, and so I get x is going to be equal to 50 RPMs. So once again, indirectly related to each other. Notice I still have, in this case, inches and RPMs, inches and RPMs. Still is the same way that way, but they're not directly because they, the 10 inches would relate to the 25 RPMs, and so that's kind of how I would approach something like that too. So the difficult thing to keep in mind sometimes is is it a direct relationship or is it an indirect relationship? And on page 370, they have a chart that will help you with something like that too, of direct and indirect relationships with that. And it's just a very simple flow chart that they use there with all that too. So they get into some more difficult, not necessarily difficult, more involved examples with that too. And so those are some things that you can look at too. But more, there, once again, it's going to be more just plugging in numbers with some of those things too. So eventually we're going to start taking a look at some of those pieces in your areas of interest, as we've done already here with all that too. But this once again is going to be on page 371. It's going to be some homework assignment that you can look at with that. And it's going to take you 1 through 38. Okay. Those are some pieces that you can look at here. Some different things that will be on the test that way. The big thing is you have to think, okay, when I'm working with this problem, the answer I'm trying to find, since the other number has gone up, I'm going to say up in my example, since the one numbers went up, should this other number also go up? Then once again, if it is, then it's a direct. But you also got to think, okay, if this number goes up, should this number go down? And if one number goes up, the other number goes down, that's an indirect. And so the numbers cannot be directly above each other with all that too. So anyway, so keep some of those pieces in mind as you go through this, and good luck. And if you have any questions, please make sure you ask. Have a great day. Bye.